Hello, and welcome to the Soil Core's video on completing your soil calculations for CEMA 221. Our group, the Soil Core team, received funding from the USDA and NRCS to help train qualified individuals to perform soil health testing. The goal of this CEMA is to monitor soil carbon before and after an NRCS implemented conservation practice. Resources complementary to the information found on this module can be found at boisestate.edu/soil conservation. In this video, you will learn how to read results from a lab, how to complete the needed soil calculations, and a walkthrough of the Soil Core Excel spreadsheet that will help report all of the needed information. A few quick reminders. Include your soil core volume, provide the height and diameter of the core for the lab, and be sure that you've requested these tests: drying and sieving, bulk density, acid fumigation, and soil organic carbon by combustion. Lab result formats can vary depending on where you submit them. You can follow this resource if you need to calculate the bulk density if it was forgotten, as well as how to calculate soil organic carbon by hand if you are interested. Depending on which lab you are working with, result formats may look a bit different. Here is one example of how results may look. These CEMA 221 labs were done at the University of Analytical Sciences Laboratory. Let's focus on client ID 100. Here we can see the sample ID that I gave to identify the sample. For reference, I used a sample identification number that I generated. We can also see that it was confirmed that the soil was acidified here and here. We can also see the bulk density, which is reported in milligrams per meter cubed, and the total organic carbon, which is reported as a percentage. As mentioned earlier, some labs may report things differently. We are interested in two measurements. First, bulk density, which is reported here as milligrams per meter cubed, but we will want it in grams per centimeter cubed. Second is the total organic carbon, or TOC, which is a percent. We will need to convert this to soil organic carbon, or SOC, which is reported in percentage, which equals the grams of soil organic carbon per 100 grams of soil. We need to turn the SOC results into grams per centimeter squared, which equals our carbon pool. From there, we can convert it into whatever units are most useful for the producer and the NRCS. We have created an Excel spreadsheet that can be used to plug in all of your values and get the results needed to report the NRCS and your producer. So we are going to enter the information provided for the example sample earlier, sample ID 110. I'm going to fill in some things for context. This was my 15 to 30 centimeter increment, and I provided the lab with fine fraction material volume only of 304.0245 grams. I will enter it in the volume column, column E. If you have coarse fraction and fine fraction, you may enter those as well. I will also enter the lab-provided bulk density value of 1.3 milligrams per meter cubed in column H. Last, I will enter the SOC percentage given in column N of 0.43%. Once all of these are entered, the formulas will take care of the conversions in calculating the organic carbon pool. Now you are prepared for completing the necessary soil calculations. If you have any additional questions, please contact the Soil Core team at soilconservation@boisestate.edu and follow us on our